So I'm either super motivated to do math or super unmotivated to clean my driveway, or maybe both, because this is only a one question thing. So first of all, I have this picture, which I will refer to in a minute. A water trough on a farm has an isosceles triangular cross section that is 24 centimeters across the top and 8 centimeters deep. That is me researching. Oh my gosh, I'm gonna excuse me. Researching coffee makers. Totally distracted myself. A water trough on a farm has an isosceles triangular cross section that is 24 centimeters across the top and 8 centimeters deep. So let's see if I can draw a picture of that. Isosceles triangle cross section, and then it'll go back and it'll fill with water. So the trough is 8 meters long, and it's 24 centimeters across the top and 8 centimeters deep. You see a problem already? Different units. If it is empty and then filled with water at a rate of, there's meters cubed, so I know its volume per minute. How fast does the water rise when the deepest point is 7 centimeters? So let's dig out our purple water again. And the height will be 7 centimeters. All right, so there's a huge problem, and that is we've got different units, and this is the overriding unit. You do not want to mess with anything that's got a per. So that means everything in here should be meters as opposed to centimeters. So I have to take 8 centimeters and divide it by 100 and get 0.8. So this, 0.08. Which makes this 0.24 meters and makes this 0.07 meters. So now I have those values. So back to this picture. If you have a trapezoidal trough, so trapezoid, that thing behind the goalie net, this is your trapezoid formula for this area right here times the length. So if I want to know an isosceles triangle, I will have to come up with a formula. So volume is a half base times height, so that's a triangle, and then times the length. So see a problem here? I got 3 letters here. I haven't actually finished this because I don't have a question mark. It says if it is empty and then filled with water at a rate of 4 meters cubed per minute, how fast does the water rise? So water rising is its height. So there we go. So let's think about the water level. So the water level, regardless of where the water level is, the water level will have this still being 8. So one thing I can do before I start to panic about all the letters is this. I can put in 8. And unfortunately, this is not like the last question with the cylinder where I get to do the product rule, in case you were hoping to do the product rule. And the reason is because we aren't given enough information to need the product rule. If I was given a BH by dt instead of, a dB by dt and a dH by dt, then I would consider it. But I don't really need to. So what I can do instead is what we did with the original cylinder problem, and that is set up not an RH ratio, but a B and H ratio. So B, to begin with, was 24 centimeters, and H was 8 centimeters. And it doesn't matter if you use centimeters or meters, 0.24 and 0.08 will still come back to this. Cross multiply. So 8B is equal to 24H. So we have to decide which letter we want to get by itself. And it's not a 50-50 choice. It's we need to keep our H's and get rid of our B's. So that means I need to isolate B. So I have something to plug in for B that looks like H's. So I'm going to do a little bit of math here. A half of 8 is 4. Turn B into 3H. I've still got an H as part of the formula. So that's 12H squared. And now I can take the derivative. So 1 dV by dt equals 24H to the 1 dH by dt. And now let's see if I've got enough info. So dV by dt is 4. dH by dt is what we're looking for. Remember that much. H will be the 7 centimeters, but because everything is supposed to be done in meters, this was a ratio, it was a comparison, so it didn't matter as long as both of those were the exact same units. I am going to put 0.07 meters in there. Calculator time. 0.07 times 24 equals 1.68 dH by dt. Wow, I'm getting messy. Sorry about that. Divide by 1.68 on both sides to get dH by dt by itself. Let's not be messy in our final line. 4 divided by 1.68 equals, yikes, 2.30. So therefore, the water level rises at 2.30 meters per minute. Let me just double check that. Yep, meters for height, minutes. All right, so you will have to decide when you've got a trapezoidal trough what stays the same and what doesn't, depending on your changing water level. So the trough problems are here. Again, challenge question would be number 10. That was very short, even though I had a whole lot of babbling in there. Sorry. Back with the last kind, which is triangles.